All right, cool. So I'm really excited about this particular topic. Now, kind of stuff that I've been working on recently is a lot around this kind of topic. Before we jump into it, I want to get an idea. Have you guys ever heard of serverless before? So a lot less hands for people that have heard of serverless than people that are new to DevOps Live. So that's pretty cool, because that means that I can keep this at a pretty high level. I can make sure that we can all kind of understand and get an idea of where this technology is going, what it is, and so if you are a dev, you should be able to get something out of it. If you are a manager, you should be able to get something out of this. If you're an executive, you should be able to get something out of this talk. So I'm really excited about it, and I titled it "Serverless is Eating the World," based on an article that I read a long time ago, actually. And so we'll talk about that a little bit further as we get into the talk. I want to give you an overview of kind of where we're going. So since a lot of you are new, I will reintroduce myself. To give you a preview, I founded DevOps Live in 2012. So some of you know me, but many of you do not tonight. After that, I will introduce the essay that I'll be referring to, and I'll use that as a foundation for this talk. The content of that essay is going to be pivotal to understand before we move into talking about serverless. The essay is really kind of broken up into 3 different sections. One is called the shift, which really talks about an economic shift that's happening. Then it goes into a marketplace impact around the software revolution. And then it talks about several challenges. And so we'll get into that. And then from there, we're going to go to a section that I've entitled Setting the Stage for Serverless. We'll do a serverless introduction, talk about some of the benefits if you choose to adopt serverless technologies, and then get into some of my predictions for the outlook of that technology and the future of some of the software industry. And so I do want to mention that if you have questions at any point during this talk, I've structured it so that way we can dialogue as those points are coming up, rather than waiting for the very end. If you had a question earlier on, want to discuss it, I want to give you an opportunity to bring it up sooner than later. So, my name is Johnny Jelinek, and that's what they call me at my place of employment. Before in DevOps Live, you know me as John, but now it's Johnny because there's too many Johns where I work. And so I've got a whole lot of experience in terms of IT support, information systems management, and about a decade as well in software development. And so, and then also over the last 5 years or so, I think we're on our 6th year of DevOps Live right now. So I've been really focusing on in the DevOps space over that period of time. And I'm a course author for Serverless Academy, and so Serverless Academy is an e-learning company. We build courses and labs that train you on serverless architectures. And so I've got courses that are online. I am really passionate about software freedom, and I get to have a lot of fun contributing to open source software. And I enjoy giving talks on DevOps best practices, the future of web development, and serverless technologies. And if you're ever trying to get a hold of me, you'll have a better job, getting a hold of me if you find me on IRC than you would on Twitter or Facebook or whatnot. So you can only find me on IRC in Freenode in the Linux Academy channel. So enough of the formalities. Now we know each other. Let's talk about the essay that I want to introduce. It's called Why Software is Eating the World, and it was written at the end of 2011, published by the Wall Street Journal, and written by a man known as Mark Andreessen. And considering this audience, you guys may know of Mark Andreessen. Let me get a feel. Have you guys heard of this guy before? Yeah, one guy. I got one guy and like 3 head nods. So okay, so he's a very well-known investor, entrepreneur, software engineer, and he's part of a software investment firm known as Andreessen Horowitz. But more than that, and this is what I think that you'll be able to identify him in the future better, is he's one of the co-founders of Netscape. And so I'm pretty sure all of you have heard of Netscape before. And so he's very well known. And so he wrote this essay. And so it talks about the software revolution that is coming, and some of the implications that go along with that. So he starts the essay off stating this. He says, "This week, Hewlett-Packard announced that it is exploring jettisoning its struggling PC business in favor of investing more heavily in software where it sees better potential for growth. Meanwhile, Google plans to buy up the cell phone handset maker Motorola Mobility, and both moves surprised the tech world, but both moves are in line with a trend I've observed, one that makes me optimistic about the future growth of the American and world economies, despite the recent turmoil in the stock market. In short, software is eating the world." What Andreessen was noticing was this trend of disruption. This disruption around software that's being added or injected into traditional companies. Companies like HP that was founded in 1939, and companies like Motorola that was founded in 1928. So they're having some significant changes because of software. And so, yeah, like I was saying, this essay was published in August 20th of 2011. And so, Andreessen, he didn't want to believe this trend, and so he got together with his colleagues and he tried to argue the other side. But in the end, the data was overwhelming, and that led him and his colleagues to state, "We believe that many of the prominent new internet companies are building real, high growth, high margin, highly defensible businesses." And what's interesting about this particular quote is that he said this at a time when the stock market hated technology companies. I mean, if you look at well-known technology companies, the stock market did not value them very well in terms of their price to earnings ratio. So for those of you that don't know what a price to earnings ratio, Investopedia can tell you what that is. It says that it's the current share price versus the per share earnings, and basically that means that it's how much investors are willing to pay per dollar of earnings. As an example, it's also called the multiple, and so if you have a multiple of 20, that means an investor is willing to pay $20 for $1 of current earnings. And so a high PE ratio suggests that investors are expecting higher earnings growth in the future compared to a lower PE ratio. All that to say, at the time, Apple had a low PE ratio of only 15.2, and so this was about the same as the broader stock market. Yes?
You said this was 2011?
Yes. That's right. This indicates that investors did not think that Apple would have higher earnings growth in the future. But this is despite the fact that Apple had immense profitability. And so, in fact, they had just surpassed ExxonMobil at that time to become the biggest company in the United States in terms of market valuation. So they had a lot going for them, and still their PE ratio was low. So all of this signifies that investors thought it was a bubble. And so one of the things that Marc Andreessen says is that you can't have a bubble if everyone is screaming, "Bubble!" And so rather than a bubble, Marc Andreessen says, we are in the middle of a dramatic and broad technological and economic shift in which software companies are poised to take over large swaths of the economy. So that's a pretty heavy statement. And this brings us into our first section called the shift, or the economic shift. And Andreessen, in that section, he made a prediction. He said, over the next 10 years, I expect many more industries to be disrupted by software, with new world-beating Silicon Valley companies doing the disruption in more cases than not. And since it's now 2017, we can analyze his prediction a little bit, see kind of how things have been going. So what I want to show you is market valuation over time. As I mentioned, in 2011, Apple surpassed ExxonMobil to become the biggest public company in the US in terms of market valuation. Well, we've got data now between 2012 and 2016, since those years are now over, and we can see how they've done. So In 2012, Apple had $546 billion, making them first place in terms of market valuation. And then second place was ExxonMobil with $407 billion. And then if you fast forward to 2016, you can see that Apple has remained in first place with $586 billion market valuation, whereas ExxonMobil has dropped to fourth place with $363 billion valuation. So I want you to take a guess at who took second and third place. What do you think?
Amazon.
So one of those that we mentioned is in the top. What? Alphabet? Yeah, that's right. So actually, you know, according to the Forbes Global 2000, their 2016's top U.S. companies ranked by market valuation is Apple, Alphabet, which is the parent company of Google, and Microsoft. And so these top three companies are all in the information technology sector. And so, you know, remember when we said, you know, we are in the middle of a dramatic and broad technological and economic shift in which software companies are poised to take over large swaths of the economy. I think we can see that, you know, some of that, there's truth in that. So you might be asking, well, you know, how did this happen? And Andreessen explains it like this. He says, 6 decades into the computer revolution, 4 decades since the invention of the microprocessor, 2 decades into the rise of the modern internet, all of the technology required to transform industries through software finally works and can be widely delivered at global scale. And so this is in part due to access, you know, reach. In 2011, there was more than 2 billion people using broadband, and even more than that on smartphones. And Andreessen made a prediction, another prediction. He said over the next 10 years, he expects that at least 5 billion people worldwide would own smartphones. And so this would give each person instant access to the full power of the internet every moment of every day. So because we're now in 2017, we can do some analysis, just like we did before. So I've actually written up, or I've created a infographic here of some of my predictions. But first, let's talk about 2011. So in 2011, what we see here is that the world population was about 7 billion people. And of that 7 billion, 2.2 billion were internet users. So this made for a 32% market penetration of internet usage, or internet users. And then if we go forward to 2016, we see that there were 7.4 billion humans on the planet and 3.4 billion that had access to internet. And so this made for a 46% market penetration. Well, based on some of the trend analysis, if you go up to 2021, which is the end of the 10-year prediction, what we see is that we have a world population of about 7.8 billion humans on the planet, where there are 5.1 billion humans that have access to internet. And so that means that the market penetration grows to 65%. So that percentage is growing at a rapid pace, and we're going to see even more people online. And so a lot of these stats, or actually all of the data up before my predictions, come from internetlivestats.com, so you can see kind of a real-time picture of internet usage growth. Yes?
Is there any validity in considering devices?
Yeah, so in 2011, IoT wasn't a thing. And so, like, in terms of Andreessen's prediction, smartphone was about, about how things, the way he could see things. Right. Yeah, no, in terms of devices, though, maybe we could get well over that 5 billion.
It's exponentially.
Right. Mm-hmm. Yeah, in terms of access and reach.
So this is driven mostly by mobile?
Uh-huh. That's right, yeah.
Some fixed connections will increase, but
exactly, yeah. And I've actually seen this firsthand. In 2012, I visited a remote village in Ghana, and those people don't even have electricity, but they all have cell phones, and they've got prepaid cards. And so what they do is they send one of the villagers over to the marketplace, and he charges all their phones for the day, and then he brings them back at the end of the day. So it's really interesting, and it's crazy to think the kind of power that telecom companies have in this wireless world over, even people like that in terms of connectivity and reach. So it's pretty interesting. All right, so to reiterate, all of the technology required to transform industries through software works and can be widely delivered at global scale. Well, how else did this economic shift happen? Cost. In 2000, the cost of running a basic internet application in the cloud was about $150,000 a month. So if you fast forward to 2011, that same application in Amazon's cloud ends up costing only $1,500 a month. So cost has dropped dramatically. And so from the essay, Andreessen writes, with lower startup costs and a vastly expanded market for online services, the result is a global economy that for the first time will be fully digitally wired. The dream of every cyber visionary of the early 1990s finally delivered a full generation later. So this moves us into the next section on marketplace impact. And from the article, the most dramatic example of how this software revolution impacts the marketplace is the example that it has between Borders versus Amazon. From the essay, it says, in 2001, Borders agreed to hand over its online business to Amazon under the theory that online book sales were non-strategic and unimportant. Oops. Big oops. I mean, this explains the rapid decline of Borders and the dramatic rise of Amazon. I mean, consider books are now software. So, this was a really bad bet to make. Yes, did you have a question?
Yeah, just another quote.
Yeah.
In '97, when Michael Dell said that he's not a CEO for hire, and if it were up to him, he would shut Apple down because there was no future in that business.
Yeah.
Where's Dell and where's Apple?
Right. Yeah. Right. Absolutely. Yeah. I mean, another example. Let's look at the entertainment industry. So Netflix versus Blockbuster. I'm sure you guys remember the story of how Netflix eviscerated Blockbuster. I mean, considering the steps required to actually watch a movie from Blockbuster, remember I had to get in my car, I had to drive to Blockbuster, I had to go find my movie, I had to hunt it down, really. I had to go in the checkout line, I had to get back in my car, drive home, I had to go and put the DVD or the VHS in my player. I had to sit through some previews for other upcoming movies, and then I finally got to watch to Netflix. I I get my phone out, I go to the Netflix app, find my movie, and I'm watching. So I mean, so many steps removed from that. And this isn't isolated to just video rentals. I mean, consider TV providers, Comcast, Time Warner. These companies are changing the way that they deliver TV to users. Now that's all happening through software, your smartphone, through tablet, through our connected devices. How about other companies like music companies, software companies? They are companies like iTunes, Spotify, and Pandora. How about movie production companies? Disney had to buy Pixar, a software company, to remain relevant in animated movies. Photography, goodbye Kodak. I'm sure you guys knew that. But maybe you didn't know, Snap Inc. announced an IPO recently. And so they're the guys who make Snapchat. And Instagram is very ubiquitous these days. And if I want quality prints, I can go to services like Snapfish and Shutterfly. Telecom. Did you know that Skype is actually considered the world's biggest telecom? They were bought by Microsoft for $8.5 billion. And so, legacy telecoms like CenturyLink, Verizon, AT&T, they're all having to change their strategy and implement software. Their legacy solutions are seeing a dramatic decline in usage. Direct companies, I'm sure you guys know of Google, obviously. And some of you also may know about Groupon. Well, did you know that Groupon made more than $700 million in revenue in 2010 after only being in business for 2 years? And not only that, they're considered one of the fastest growing companies to ever reach a valuation of $1 billion after just 16 months in business. So pretty crazy, but yeah, lots of growth. LinkedIn dominates the lucrative $400 billion recruiting industry with its ability to offer recruiters access to employees' resumes in real time. Now, what about products that exist primarily in the real world, like cars? Well, cars are now powered by software that runs the engine, controls safety features, entertains passengers, guides drivers to destinations, and connects each car to mobile, satellite, and GPS networks. But furthermore, what about hybrid and electric powered cars? Those only accelerate the software shift, and driverless cars are well underway. Think also about companies like Walmart and FedEx. They're being drastically changed by software, and that software powers their logistics and distribution capabilities. How about oil and gas companies? Well, they depend on data visualizations and analysis in oil and gas exploration, and agriculture uses satellite analysis. What about the financial sector? Many of the leading innovators in financial services are software companies like Square and Stripe. So, in short, Andreessen's point about the marketplace impact is that companies in every industry need to assume that a software revolution is coming. And he says this is a profoundly positive story for the American economy in particular. It's not an accident that many of the biggest recent technology companies are American companies. Our combination of great research universities, a pro-risk business culture, deep pools of innovation-seeking equity capital, and reliable business and contract law is unprecedented and unparalleled in the world. So, this concludes the marketplace impact section. You can see that there were some pretty dramatic changes as a result of the software revolution. Does anyone have any questions at this point? No? All right, we'll move on. So the next section is labeled several challenges. And so in this, Andreessen will tell us that even though, even amidst through this software revolution, there's still several challenges that impact us. So the first one is economic challenges. So the economy looks a lot different today than it did in the 1990s. And so new companies that are spinning up in this kind of environment are going up against some pretty heavy economic headwinds. What that means is that the companies that survive in this market will end up being in a really good position when the economy stabilizes even further. And so they should be able to see some pretty massive growth. Another challenge is the lack of education and skills. And this is a big one because these industries that are being impacted, they're going to have employees in those industries that find themselves on the wrong side of this software-based disruption. So people that are in these industries and have been in these industries their whole life, they're going to find themselves in a place where they're not going to be able to continue doing their job. Grows, and there's even more disruption. So, this comes down to a lack of education and skills. So that's a challenge that needs to be tackled so that way more people can enter into this new economy. Another challenge is that startups still have to prove their worth. It's not easy to build strong cultures, establish competitive advantages, and justify rising valuations. So it's incredibly difficult. But the companies that can rise to the challenge and perform and exceed the kind of expectations that Andreessen has will be in a really good position, yes.
So the other day, Mark Cuban was commenting on the education skills and how what you just said may be a very temporary equation where even those who are software savvy will be fewer and fewer because fundamentally we're teaching the computers to do more and more, which, okay, today that's the physical workers, but it won't be long toward. So to some degree, I think it poses a dilemma on us as a society. How do we do it?
Yeah.
Because you can't have 1% of money nobody else. So,
yeah, it's some pretty hard challenges. I'm still at the place where I believe that no matter how sophisticated the technology, it still takes people. Now, maybe less and less people, But at the end of the day, it still takes people. Someone has to understand what's going on, and the less people that understand what's going on, then the less people that will be able to maintain what's going on. So I think that it still takes people. But yeah, I could definitely see where Mark Cuban is going with that train of thought. And there are some other implications that come out of that, like some people think that if Apple ends up taking the majority of the economy's revenue, will they end up just distributing money differently than the free market economy would be? And so, like, it's pretty weird to think about some of those implications. But yeah, it could also have some large-reaching implications for governments as well. So, but maybe that's for another time. Yeah. Any other questions at that point? No. All right. So, yes.
I just think it proves that you just can't look at technology in a silo.
Yeah.
There are ripple effects, other ramifications to consider.
Yeah. Yeah. Absolutely. And so that brings us to the part of the talk where we're done talking about the essay. The essay is over at that point, but it was 2011. But this sets the stage for kind of where we are now. And I say that that's setting the stage for serverless. And to give you a better understanding of what I mean by that, I want to introduce you to the eras of provisioning compute, in which the way software was delivered, the way that value was given to customers has changed dramatically. So as I go through some of these eras, I think you'll understand more kind of what I mean. So the first era that I want to talk about was between 1994 and 2003. And companies required significant investment to provision the necessary compute to run an application. And so they had to budget, plan, connect, power, house, and purchase hardware for their applications. And the time it took to realize value was measured in years. So I call this the pre-virtualization era. So pretty sure you're familiar of maybe your company having to rent space in a data center, do all those activities, the budgeting, planning, connecting, powering, all that for your Windows or Linux servers and whatnot. And it ran on bare hardware primarily at that time. So that's the first era, the one I'm calling the pre-virtualization era. Next one, between 2003 to 2007, enterprises began to adopt on-premise virtualization technologies. And so many companies today still rely on VMware behind their firewalls. And this technology provided a layer of abstraction over the physical hardware. And it had some benefits. It resulted in hardware consolidation, better CPU utilization, and the time that it took, or the time that it was required to realize value, was measured in months. So I call this the virtual machine era. So how many of you are still running VMware? Yeah, so I see some hands. So this came from that era. All right. Between 2007 and 2012, cloud vendors began to experience growth with infrastructure as a service. Cloud providers would offer APIs to programmatically manage the infrastructure, giving virtually infinite access. So the technology provided yet another layer of abstraction over the physical infrastructure that would host your virtual machines. And so the time that was required to realize value was measured in hours. So I call this the IaaS, or the infrastructure as a service era. And this was the era that we were in when Andreessen wrote the essay. Finally is the era that started in 2012 to the present. And so we are seeing a new paradigm shift. Monolithic applications are being broken up into microservices. How many of you are going through a transformation that sounds like that? Right? Yeah, I see some hands. All right, and so this results in even shorter time to provision compute units. And the time required to realize value is now measured in seconds. And so I call this the serverless era. So I'll explain what I mean by that in just a moment. But we went from years to months to hours to seconds, all within the span of 2 decades. So we're seeing some significant change over a period of time through these eras. And so now, at the time the essay was written, all industries experienced disruption due to software development and adoption. And the next phase of this disruption is now at hand with serverless. And so, so now let's talk about serverless, what it is. And so in short, it's another layer of abstraction, just like we've seen with all of those other eras, the introduction of technology that does some kind of abstraction. Serverless provides another layer of abstraction that ends up providing, it ends up handling a lot of the undifferentiated heavy lifting. So things that you all end up having to do that isn't specific to your app. So it handles things like logging, it ends up handling things like servers, all of that stuff ends up being abstracted from you. And so, so we'll talk about that more. But at first, it's hard for people to wrap their minds around this new paradigm shift. And I hear lots of concerns like, is my job getting automated? And what am I supposed to do? And so, I want to calm you down a little bit. It's not that bad. Change is hard, but we can make it less scary by talking about it in more detail. So typically, when someone is referring to serverless, they're usually referring to backend as a service or function as a service offerings. So BaaS or FaaS. And BaaS offers BaaS offerings include commoditized storage and compute services. And so an example of that is Google's Firebase or Parse, if you've ever heard of Parse. That's it was actually open sourced by Facebook recently, but before then it was a service that would provide an SDK that ends up basically doing all of the responsibilities that a backend would do. And Firebase still does that today. FaaS offerings allow you to build a customized backend. And so an example here is AWS Lambda or Azure Functions. And so basically here, you provide a snippet of logic that is grouped together, and then they end up handling all the hosting, logging around it, further measurements, metrics, and you get charged a whole lot less, and we'll get to that in just a minute. But in terms of the term serverless, FaaS is becoming much more popular. So when I hear people discussing serverless these days, it's almost exclusively referring to FaaS. But technically, serverless is BaaS and FaaS. I dare you to say that fast, over and over again. BaaS, FaaS, BaaS, FaaS. Yeah. All right, let's talk about some benefits of adopting serverless. So whether you're using BaaS or FaaS, or both within your applications, you will gain some of these benefits. First is that you will write less code, and that's good for everyone, because less code means less bugs that you're responsible for. Also, scaling will be someone else's problem, and cloud vendors offer virtually infinite scale. Also, your bill goes way down. So if you're using BaaS, you're charged usually for storage or access to that storage. If you're using FaaS, you're normally charged in increments of 100 milliseconds, and that's based on how long it takes for your logic to execute. And so for enterprises, this is a simple optimization where the total cost of ownership drops dramatically. And so this is because businesses don't have to rent space, purchase hardware, or install infrastructure. Also, the compute cost is based on the number of code executions. And so this is measured in hundreds of milliseconds instead of hours. Compare it to your EC2 equivalent. Even if you use a minute of EC2 that was provisioned, you're still going to be billed for an hour of it. Whereas here, you're going to be billed in an increment of 100 milliseconds. Also, FaaS encourages the development of microservices, which do one thing well and is deployed independently of other services. So it's not a requirement for you to have to use FaaS if you're using microservices. However, if you are doing FaaS, you're almost always writing microservices. All right, these microservices are released in smaller deployable units, which results in faster delivery of features to the marketplace and increased ability to adapt to change. And so all of this introduces more agility for the organization. But for smaller shops, like individuals and startups, this is a great democratizer. Yes?
So I'm very familiar with infrastructure as a service.
Mm-hmm.
I have some inkling of what you're saying, but I mean, Can you provide a couple of examples of how you get there from here or whatever?
Yeah, sure. So, so one of the challenges, and I didn't really cover the cons as much in this talk as I do in my serverless course. However, it will require some re-architecting within your organization for you to take advantage of serverless. Yes.
Let me give you two simple examples, right? You have a static web page with just some basic information. Normally, that static web page has a contact us form on it, right? Typically, in the old world, you'd have to stand up a server to be able to answer the response from that contact us form. In a FAS environment, those static, what is static about that just sits on a static file share with web server like an S3 with a CDN in front of it, and you pay next to nothing for hosting of those static assets. Then you create a serverless receiver of that contact us post on something like AWS Lambda or one of the other FAS providers. Now, instead of paying for a server that needs to be up 24/7 to answer any possible answers or posts of that contact us form, I am only charged for the 3 milliseconds that it takes to actually receive that information and send it to me, or grab that information and forward it to me in an email or send a text or whatever, right? So that's a really just myopic small example of now, instead of paying $10 to $30 a month for a server, I'm paying pennies for those milliseconds that it took to answer that contact. That's
Right.
just a real boiled down definite example of serverless.
Yes.
Is contact us an example of what you call a microservice?
Yeah, because it's just its only purpose and existence in life is to answer the receipt for the thing. And so you have services that just say, hey, just take my little piece of JavaScript code or whatever, and all I do is contact us and pay me, $5 a month or something, right? That would be a commercialized microservice.
Yes.
Okay. Yeah, it's a great benefit, but can you think of from a developer perspective, right? So I just have to worry about my code. I don't have to worry about my infrastructure. Right?
Mm-hmm. That's right.
But how do I develop, the code in my local environment?
Mm-hmm.
Right? What type of setup I need to have, right?
Right.
Deploy into
No, it's really not much different than if you were building a REST API and you would have some tools to test that. What it's doing is pushing all that needed but non-differentiated, love that, by the way, like stuff into the service, and then clearly you're just dropping in this little piece of code. And of course there's tricks, right?
Right? We always complain, right?
Yeah.
It works always in my machine.
Yeah.
That's not work somewhere else.
Right.
But essentially here I'm developing in my machine, but I'm defined somewhere.
Right. So the way that that a lot of people kind of handle some of those nuances is so each of your deployable units of code have to adhere to some contracts. And so, so your contract is a signature that your application is to start with. So for example, in using AWS Lambda, you have to accept a handler, a context, and a callback. So if you're writing in JavaScript, you accept these 3 parameters, do your logic, and then spit something out. So as a developer, if I want to mock those 3 components in my own test harness or whatnot, execute the stuff, and then do unit tests that tell me what my output should be. If it works there, I can do an integration test by deploying it and then trying it out in my acceptance test environment or whatnot. As it goes further, then you move it down the chain to production ultimately. Yeah.
Thank you.
Cool. Other questions about this? So basically, oh yes, go ahead.
So in that environment, I want to store every contact that's made and the response and all that. So how does that play into this model?
Yeah, I think in my example, no storing, just receiving, like getting an email from the contact us post. But there are examples of, let me just use a slightly different example. I have something that's logging, right? And normally in the old world, you'd set up a cron and you would say, I want to process my log every hour. Well, in this new world of serverless, the log file getting placed on the files on S3, for example, is an event that ends up, and so you mentioned events, handlers, these things.
Callback.
So any event becomes a trigger to start that server process. So I would not, I think the application of an always-on storing data kind of service might not fully fit into our simple examples, but people are using like serverless endpoints and then pushing data into DynamoDB or some kind of persistent storage.
Yeah.
People are building whole applications using the serverless infrastructure.
Right.
I don't know that I buy that
There's-
totally, but
Right, yeah, I mean, there's this debate right now on whether DynamoDB is considered serverless. I mean, in a way, it's a backend as a service component, so that would then fit it into serverless. However, with DynamoDB, you're still responsible for capacity. So, and so that kind of removes it from the serverless world a little bit, because that's a concern that you have to be aware of. Yes? Yeah, so Aurora is just part of RDS. So I mean, in that regard, you're still having to manage number of instances, or and you have to do data migrations to handle growth. So I would definitely say that RDS-related databases are not considered serverless. Yes.
The way I was able to wrap my head around serverless was thinking if anyone uses, command line, Linux, Unix, and you do piping, whereas you have various events, operations, the outcome of one feeds into another. In essence, that's how I got my head around serverless. You think about your input and your output, and the in-between is a different function. And you can chain them together, like you were saying about your response. So in that example, the output of someone triggering that event, the submission would be the input into your response. Right. So you would just write another function that would accept the submission as an input, and then it would perform whatever you wanted it to execute and spit out, be it log it somewhere or send an email. That's how I got my head around it. It worked for me. I don't know if it.
Yeah. So ultimately, there's the paradigm shift is that developers change their mind around managing applications and servers, and now they're thinking about their what they deliver in terms of tasks and process flows. So it's a lot more granular, and they're deployed more independently.
So with this kind of serverless, what we are looking at, like what I'm looking from this is like it's a kind of services that which provides like a mediator where it actually transfers the services between the host and the requester. But what kind of security do we really see in this kind of environment where where the data transfers between these areas, like a server which actually process this request and all. So how do the encryption or what kind of data would actually see that the end client will have that kind of trust on these services that my data is encrypted or has a security?
Right. So in some cases, at the edge of the data going from your computer into the data center hosted by AWS, in some cases, that's an exercise for the developer, where you're responsible for deciding what you're going to do about like using HTTPS. You're going to be responsible for handling any kind of like authentication tokens and whatnot. And so AWS makes it a little bit easy. They've got something called the API gateway that they also provide, which lets you wrap on top of your Lambda functions, or your Lambda handlers, as they call it. And so that ends up providing some of the HTTPS stuff, and also lets you set up a custom authorizer where you put in another Lambda function that executes the logic of token.
So what, as per your comment, is like it is reducing the cost. Then in that case, it is not a dedicated server which only process your request. Rather, it is shared resources which will be also processing the other environments as well.
Well, but that's how, I mean, in terms like of the number of servers that are underneath that are totally hidden from you, I mean, if it's a shared environment, it's not that another person who has an AWS account is going to also be charged on you because it's on the same hardware. No, I mean, it knows whose account it's associated with, who should be charged ultimately because this logic is executed. So it should be totally isolated in that regard.
Yeah, AWS their stuff is more secure than I can make my data center good, right? So as a developer, it's on you to take care of that level up. Right? You need to make sure that your applications are secure and that all.
Right. I mean, after it gets inside of their data center, I mean, it's like they have things like encryption at rest and other kind of things that that really make it impossible for people in their own organization, amongst others, to actually do something bad with that data, unless, for example, you end up putting your API access key and secret to AWS, to the AWS CLI or any of that in your GitHub repo and somehow publish that. Then you're stuck. Like, you're in a bad place then. And I happen to have bad stories about that. But so don't do that. Like, just delete the repo.
Other people, it's great GitHub just to look
Yes,
at it.
that's
They'll
right.
stand up thousands of servers, but let me tell you, these guys know how to write the code.
That's right.
And before you know it.
Yeah, absolutely. Other questions? Yes.
Cloud operator or sysadmin comes in.
Yeah, so that's one of the scary parts, right? because the things that are normally done in the world for a sysadmin is being commoditized, being automated. However, like right now, serverless technology is still pretty immature. That doesn't mean you shouldn't use it, but there's still a place for people that are responsible for metric gathering and analysis of those metrics, log aggregation. And so you kind of think of the sysadmin role changing from someone who just maintains systems to someone who understands the data and can tell what the real flow of data and the way that you end up actually receiving value out of the system. So does that make sense? Yeah. Yes.
So that's what we're referring to at my company is big data for IT, right? We need live statistics at every single layer to evaluate the inputs. A lot of people are already doing this when they're taking a focus at intrusion detection, right? So remove intrusion detection out of that. Is my app working correctly? Is my storage working? Is my network traffic routing? Are my users consuming the information? What functions are they using? What APIs are they calling? That's where it's really going.
Yeah, absolutely. So we talked about enterprises and how serverless is a small optimization in some cases. For smaller shops like individuals and startups, this is a great democratizer. So one example of how serverless technology impacts organizations, you can take a look at this example with Compelling Science Fiction. They are a magazine created by people who believe that science fiction is important. And serverless technology enables them to automate their article submission, editing, and publishing processes. And so this gives them high availability with scale, globally available, and all at very low cost. Another example, serverless technology also enables research labs like UC Berkeley's AMP Lab to scale out their data science efforts, running huge jobs with costs reaching a few cents per execution. So they're running big data jobs, actually, but using AWS Lambda, for example. And so this is significant savings when compared to other big data offerings such as Redshift or AWS's Elastic MapReduce, which those are Hadoop based big data offerings. All right, so that's benefits. Let's get into some of my predictions. And so in order to do this, I want to introduce you to the Gartner Hype Cycle. That's this here. There's 5 areas, and so this shows people's expectations over time of technology when it's introduced, and it has to survive these areas. And so these areas are called the technology trigger, the peak of inflated expectations, the trough of disillusionment, the slope of enlightenment, and the plateau of productivity. So I believe that serverless, particularly FAS, is at the peak right now. And so please allow me to wrap up with some of my predictions. Number 1, over the next 5 years, I expect many more industries to adopt the paradigm shift away from applications and servers to tasks and process flows, utilizing serverless offerings. Number 2, over the next 5 years, I expect standardization and growth in education around software engineering and technical training for the top cloud vendors. And number 3, finally, over the next 5 years, I expect FAS to be seen as cloud computing 2.0 as it survives through the trough of disillusionment. All right, so Software is eating the world. Serverless is eating the world. That's all I got. So you can catch me on Twitter if you have to, but normally on IRC, you know. And also, if you're interested in this topic and more, I've got some content up over on Serverless Academy, and so we can go check that out real quick. So I released a class, an online course called Serverless Concepts here at the end of November last year, and it's already had 3,900 students go through it. So it's getting some pretty good notoriety. It's free right now, so you just got to, at serverlessacademy.com, click the get free access button, and I've got some other content up here as well, but that stuff requires a subscription. So that's how they make money. So cool. Any questions? Yeah, so as I mentioned at the beginning of the talk, so Serverless Academy is an e-learning company, and so we build serverless architecture training courses and labs. And so right now, we're distributing that content through either Udemy or Linux Academy, which is another e-learning company. It's our sister company. And so Linux Academy has a subscription cost for it for their paid tier. They also have a free tier as well. So that's kind of how I distribute it right now. And yes. Yeah. Yeah, so here, let's go to the course a little bit. All right, so it's about 2 hours in length, 15 videos, and 1 download. But it covers things, which I don't know if you can see that. Let's get a little bit bigger. So things like Google Firebase, AWS API Gateway, AWS Lambda, Azure Functions, IBM Bluemix, OpenWhisk, on-premise stuff like Parse. We talk, at a high level as well. What is serverless, traditional versus serverless architectures, ways to get started, production examples, benefits, caveats. I mean, I've almost named all of my sections, all of my lessons. Yeah. So, but yeah, like I said, this course, you can get access for free without doing this trial. Actually, if you go back to serverlessacademy.com and click on the Get Free Access button.
What's the level of foundational knowledge you expect your students to have?
For this course, none at all. It's total introductory, and it's meant to be the foundation for some upcoming courses that I'm developing right now. So, yes.
So, are there any maybe tools that can help you use with Node.js development to make sure that I'm following the best practice of serverless architecture and not overrunning on my times and things like that? And what maybe functions that exist within there? Yeah,
so I don't know of linting tools other than, I mean, for serverless specifically, it would almost be where, well, so one of the challenges also is with AWS Lambda, for example, you're responsible for setting the amount of memory container. And along with the memory, what gets set is also the number of CPUs. So you would almost need to mimic that exactly, maybe in your own VM or container on your own machine if you're trying to actually mimic and get those results. Or you just run the stuff in production and watch it fail. So when it fails, what's going to happen is it's going to start pushing info to your CloudWatch logs. You can start to analyze that, but you also see it in the metrics as well in the AWS console. It'll show you like the number of executions, the number of errors, the length, how long it took to run over time. So in a way, you'll be able to get some of that stuff. But I wouldn't expect that linting or like unit testing would be able to necessarily give you good answers on that stuff. Yeah, so sorry.
There is a plugin for a linking tool for serverless. Looks like it's fairly new, so you'll be able to contribute to the website.
Oh, thanks.
Yeah.
Yeah, it's like a harness / kind of watches out. You get the very similar results that you would get if you're running AWS, so it kind of helps you with the development of it. But I would say, just mentioning that it's immature, just the whole pipeline of I do a code change, I test the code change, I deploy the code, it's a little weak. I think, for my serverless stuff, I don't typically think that I need to have like multiple environments. I'm kind of like, it works, I push it, I watch logs.
Right. Yeah. Yes.
So I do get this whole serverless thing of microservices spinning out and running it somewhere. and pardon me for my question, and if you have any question, I'm not from the Java background.
Sure.
Is it realistically possible to break down the entire monolithic application into microservices? I mean, I hear everyone talking about that, but thank you, John.
Yeah, sure.
Is that
Yeah.
really possible?
Yeah. So, so I think the question shouldn't necessarily be, is it possible? Because I think it's possible, but I think the better question is it practical? Like, is it going to give me a big enough return of investment? And for larger enterprises that have a lot of legacy applications, it might not, like the juice might not be worth the squeeze in some cases. However, for some newer projects or for projects that definitely need some rework, refactoring, they can start to break up those applications. The thing is, it's not one or the other. You don't have to be fully serverless. You can be partially legacy, you know, server being legacy in this case. That's right. Yeah, you can be partially, you know, in server. Yeah, partially monolithic, that's right. And partially serverless, just depending on where you want to optimize. I mean, like I mentioned, you know, for some organizations, it's a simple optimization. Well, it's an optimization because it's bringing down their total cost of ownership. You know, for the things that are costing them the most money, it might be worth it for them to change their architecture a little bit.
I think it's important to make stage appropriate recommendations. So if you're in an organization that's very monolithic, probably the next thing is like, okay, let's break some of this stuff and start deploying some smaller apps. If you're already in a microservices type company, then serverless stuff might be great recommendations, but it's talking about like stage appropriate things. In my business, we run into a lot of companies that are not making stage appropriate decisions, and you know, we hope they're around, that those decisions don't end up ruining them. So I agree with the juice may not be worth the squeeze, because if you're in a monolithic application and you start recommending at least large swashes of serverless, it may not go well for you.
Right. Yeah. Yes.
I know this is not a microservice discussion, but I do have one issue where I'm facing right now at my place that I'm working right now. Yeah. So the UI framework or everything, you can always split into multiple. Let's say I have a big wad, I can split that into multiple jobs, right? Depending on business capability and whatnot. But how about I have a larger database, right? Where I have like a big 50 to 60 tables. When I break that database into multiple, how do I do that, right?
Right.
I can break my wad into multiple jobs.
Right. So what I would say from my experience is that a lot of, so there's this concept called domain-driven design. And so it's actually like a larger topic, but if you go through the exercises that it talks about, and the principles through domain-driven design, it talks about things like a domain layer, and it talks about breaking up. Like, it was really what I think part of the renaissance to this return to service-oriented architecture. And so you would almost, as part of the deployment and the strategy of breaking up the service logic layer, you'd also do that with the database as well, like the persistence layer, where instead of having a bunch of tables in the same database, you would actually have multiple instances, multiple database instances, each with its own, you know, subset of the tables, and then you have integration layers where the only way to access that table and to go through it, it's not through like SQL joins, but through the contracts associated at the service level. Does that make sense?
Oh yeah, sure.
Yeah. So does that answer the question?
Absolutely.
Okay.
Thank you.
All right. Other questions? Cool. I think we're only 1 minute behind. All right. Yes. Did you have anything else?
No.
No? Okay. All right. Bye, everyone online.